Never expected to see one of those down in the basement. Hello everyone, welcome back to Adrian's Digital Basement. On today's video, well, this is an Apple Lisa. And as I just said, I really never thought I'd have one of these things because they're so expensive. And this one was donated to the channel by a friend of the channel, AJ, up in Seattle. Same person who actually gave me the Pervets 8D computer I've recently shown on the main channel. And with this Lisa, which I think is a Lisa 2/5, I think is the model number. Well, even though it's complete when it comes to all the panels on the outside, the inside's in really rough shape. So in today's video, what I want to do is take this thing fully apart and survey the damage, basically triage this machine and see how bad the damage is. Because one of the problems with the original Lisa and the Lisa 2/5 like this one is it has a battery that leaks. And unfortunately, if left unchecked, causes massive and substantial damage to the internal boards in this system. And I think that has happened to this. And since I've never really touched or worked on a Lisa before, this will be all uncharted territory for me, at least taking this thing apart and, well, examining how bad this system actually is. So without further ado, let's get right to it. Now, the reason why I never thought I'd have one of these is they are worth so much money, which kind of boggles the mind because it's not a very useful computer. A Macintosh Plus is far more useful than this thing. But just the fact that, of course, this thing was a failure and there weren't that many of them and they're not that useful compared to a Macintosh means that there just aren't that many left and therefore they're very expensive. And I think the whole leaky battery damage on the back, which we're going to see in a second, I think contributes to that because there's a 0% chance this thing can work, at least in the state that it's in. Now, one thing about the Lisa versus a Macintosh that's interesting is that it's got a larger CRT, I think 12 inches, internal 400K floppy drive on this particular Lisa 2 versus the original 5¼ inch, aka Twiggy drives that were on the first Lisa. And yes, those 5¼ inch drives are weird because they actually have two read-write heads on them that operate at the same time. To give you an idea how big the Lisa is, in case you haven't seen one in person, this is it compared to a Mac 128. These were released just about a year apart, and as far as I'm aware, the design teams that worked on both these machines was different, which is why the design language of the two machines is so substantially different. Now, this Lisa 2 has the 3.5-inch drive on it versus the original 5¼ inch, and the slot opening is very similar to the one that's on the Macintosh, but I think this revision of the Lisa came out at least a year later than the original 5¼ inch version, which is why it probably borrowed the design language of the floppy drive from the Macintosh. Although oddly, the Macintosh has a hole for manually ejecting the disk, while the Lisa does not. And I assume that's because the front cover can be removed relatively easily from the Lisa, so if you need to get the disk out of there, you just pop the cover off and then manually eject the drive. Now, one of the reasons why there's such a big size difference is that the Lisa actually has quite a bit of expandability. There's 3 card slots that are available for user expansion on the back side of the machine. It also had 2 floppy drives with the original version, though this later version only has a single drive. The subsequent version of Lisa after this one actually had an internal hard drive along with the regular floppy drive. So I think that's existed up here behind this cover. While the Lisa CRT is 12-inch versus the 9-inch on the Macintosh actually featured square pixels, which made it really good for rendering fonts and the whole desktop publishing thing, while the Lisa actually had a resolution of like 730 by 384, something like that, kind of similar to MDA on the PC. And that resulted in non-square pixels, so everything has a bit of a squished look on it compared to the Macintosh. And later Lisas could actually run Macintosh software. I don't know if that was a hardware or a software thing, but the CPU in this is slower, so 68,000, it's not as fast as the Mac, so it ran it more slowly, and while you had a higher resolution, it actually resulted in everything looking kind of squished versus how it looked on all the Macs, which had that whole square pixel thing going on. There's a fascinating documentary on the Apple Lisa, which if you haven't seen before, I'll link to it down below. It really talks about the creation of this machine and the demise of this machine and all the people who love this machine and tried to keep it alive for years and years. And this machine, a lot like the Apple III, which was the failed sort of business successor to the Apple II, it was just an interesting footnote in Apple's history, where Apple had these divergent development teams really working on a bunch of different things all at the same time. And well, this and the Apple III were something that happened around the same time and were both such colossal, expensive flops. Anyhow, that's enough about the history. Let's take a look at this machine. So the plastics are in decent shape. It's very dirty and has scuffs all over it, but it doesn't seem like it's got any cracks on it, even though this machine has definitely seen some abuse. In fact, I think the whole chassis might be bent, but more on that in a bit. You might be noticing this tape, and it says opened and resealed by German customs. Yes, this Lisa actually made its way to the US from Germany. And AJ, the person who gave this to me, actually did say that this came from a seller in Germany. And this was the way it came. The whole machine was sort of disassembled and then taped back together with this tape. And, you know, there's a little piece sitting here that I guess broke off. And part of me worries that this disassembly process actually resulted in further damage to this computer, at least to the chassis and the plastic case. But I won't know for sure until we take this apart and look at this in more detail. Here's a look at the side profile of the Lisa, and luckily both of the side covers are on. These are removable. We have a bit of a staining, maybe there was a sticker there at some point. I find the design of this very workstation-y or terminal-like, with the fact that the keyboard, I guess, could slide under the computer when you weren't using it, just to kind of make some more space on your desk. The backside of the Lisa actually just has an Apple logo. It doesn't seem to have any other badges. Maybe there were some at some point, but they're gone at this point. It doesn't say Apple Lisa. On the left side, we have those 3 expansion slots. So we have the slot covers that are metal and still in place, luckily. Reset switch, video out, which I think is a odd thing. It looks like it's composite video, but this definitely doesn't have normal NTSC video. So I don't know what monitors could actually be connected up to that. There's a parallel port, mouse port, serial A and B. As far as I'm aware, the 5 in the Lisa 2/5 meant the parallel port was connected to a profile hard drive. And that was a 5 megabyte external hard drive. And this is not for like a normal printer. This would be for the hard drive specifically. On the right side of the machine is where the IEC mains input would be for the power supply. And it would have been a 240 volt power supply for the German market. It's missing. And sadly, this thing would have had some kind of fasteners. They look like a twist lock thing for attaching the back cover. This one is kind of still intact. That one is missing entirely. Surely a result of the German customs people not knowing how to open this, and they kind of brutalized the computer. So back cover just lifts away, and we get our first glimpse of the inside of the Apple Lisa. So indeed, power supply is just entirely missing. AJ never got that, so who knows if it was in this machine originally or was taken by German customs, because, you know, contraband power supplies can't be shipped internationally. I don't know. Here are the evil batteries that have puked their guts all over the inside of this machine. And you can see that there's just so much corrosion, and there's a chassis down there, like a main board that has slot connectors, because behind this, as far as I'm aware, there are more boards, like with the CPU and other things. And you can see that even all the way over here on the left side, that slot is full of green crusty. So that corrosion has made its way all the way over here. Now, if you're wondering about these, this is interesting. I haven't seen this really before, or at least on an Apple product. The Plexus P20 is something similar to this. If you turn these levers, it actually opens the slot, which releases the pressure on the card and makes it very easy to get them in and out of the chassis. You should be able to see that there is just severe and substantial corrosion all on this board. So capillary action from the leaking batteries has made its way all over the board here, and not just down to the lower area. So this looks kind of bad. Maybe we'll be lucky and like I could clean this corrosion off and there won't be a bunch of eaten traces, but I'm highly doubting that, just because we know these batteries have just been sitting there dumping their goo, or they've already done that, and this has just been slowly eating away all of this stuff. First things first, I need to just take this thing apart fully, see what kind of damage we're dealing with, if there's physical damage from the custom stuff, and then really focus on taking a look at the boards just to kind of see how bad things actually look. And I'm really thinking that there is some physical damage because the whole machine rocks quite a bit, and the top cover, which while on the front looks like it's installed properly, it lines up properly along the front edge, but on the back it's like shifted over to the right on both sides. You can kind of see the gap on this side, and it is sitting flush along the front edge, so I feel like that is some kind of damage there, that the whole chassis is twisted. But if it's metal, we can bend it back. Let's start the disassembly. I did some reading, and it seems that first step is the front panel needs to come off. I think there's something you push with your fingers here. Oh, there we go. Bottom comes off, the top comes down. Okay, cool. So that's not broken. It's all pretty dirty, but it looks to be pretty much intact. This is, as far as I'm aware, a single-sided 400K 3.5-inch floppy drive. It's gonna be hard to make out, but there's a sticker here. It says December 1983. So that's a pretty early floppy drive. And kind of curious, you can see that there's an adapter board of some type back there. I'm assuming whatever allows a 3.5-inch drive to work on a Lisa, because this was originally designed with those 5.25-inch drives. It appears like we have a thumb screw at the bottom. See if we can get this drive out. I assume it slides out. Oh, that comes out, okay. Lots of spider webs, German spiders, I guess. Free the ribbon cable that comes from the motherboard. I'm not 100% sure with the floppy drives that are used, but I'm assuming this is just like the 400K floppy drive used in the original Mac 128 and 512. Also curious, is there some kind of a slot or opening back here that goes from this area into the card cage? Don't know if that was what the original lease is, or maybe that's for an internal hard drive upgrade you could somehow install in this area using an adapter card. Now let's get back to the CRT. With the front bezel removed, we can see how dirty this is around the edges. I'm very curious though. Let's clean this off a little bit. I think there's some burn-in on the screen. I could actually feel that this machine is probably relatively high hour, although, you know, I don't really know for sure because the thing is pretty dirty and not all of the dirt, I think, comes from use. I think a lot of it was from storage. I don't think it's going to come across totally clear in the camera, but I can definitely see what looks like an Apple logo and a menu bar along the top where the white menu bar is burned into the phosphor. And I can see what looks like icons along here. And even down here, there's icons and stuff. So you definitely can kind of get an idea that this machine is relatively high hour. I don't know if there's anything special about this CRT. The tabs themselves are towards the back of the implosion band. Obviously, if you put a green CRT in here, it's going to be kind of obvious that it's not right. This is definitely a P4 white phosphor CRT. You can kind of tell by the UV flashlight here, just the color that shines. That's that whitish color. All right, next up, I think you're supposed to remove the whole card cage thing on the back, but this thing has never been fully reassembled, so this top lid is actually just sort of sitting on top there. We can kind of get an idea how much use this has just by the soot there. The front edge of this top cover just clips on the front using these plastic clips. They are not broken, luckily. And then there are two fasteners that would have gone in from underside where the card cage is. So they've obviously had the card cage out to remove those fasteners, and I don't have any of those fasteners. They're all lost, right? It's kind of amazing. Again, I assume this is all from the German customs. They completely brutalized this computer. But I guess I'm glad at least that I have all the covers for the machine, so at least you can put it back together in a way that kind of looks complete. All right, sorry for the handheld shaky cam, but there is the top-down view. That's the CRT driver board and the 12-inch CRT. It's made by Clinton, same manufacturer as a lot of Macintosh CRTs. I'm sure the Lisa is highly documented, but there's the part number of the CRT in case you're curious. So now the card cage should come out. I'm not sure there's actually any fasteners. I think the back cover normally holds this into place. So I'm just gonna try to pull this out. Yep, there we go. Oh dear. Oh boy, I see a lot of corrosion in there. Okay, turning this around. So this is the second board. The one we can see with the back cover off is not this one. There's another one. There's the CPU, Motorola 68000. It's 8 megahertz spec, but I think clock speed's actually less. There's a RAM board. Looks like there's a space for another RAM board. We'll take a look at those a little bit closer, but there's a ton of corrosion all through this area. Oh boy. You can get a little bit of an idea of the corrosion. Look, it's sort of falling out of the machine. This looks pretty terrible. These connectors are all corroded. This one is just sort of floating in there. I have to imagine that would originally be screwed in there. This one is screwed in, but actually it looks like there's a whole bunch of cables just sort of wrapped around back there. Like there's another connector that's just loose down there. I think the power button, the keyboard connector, that all must have gone to that connector. Maybe that's what some of those extra wires are. If you're wondering what this is, you think it's a transformer. It's not. It's actually just the back of the CRT. At least one connector that's not corroded is this one back here for the power supply. So that's something. Next up, I'm going to try to get these side covers off. I have a feeling these are the fasteners. There's one there, and I see some along the top there as well. Two more fasteners on the front. And I think this side cover is not quite released. On the right side, there was one more fastener that I could get to from the drive cage. So everything looks fine there. We actually have metal inserts. That's nice. Nothing's cracked or broken. It's just dirty, but excellent. With that side cover removed, I feel okay putting the machine on its side because now it's sitting on the metal chassis. And I can see why it was a little wobbly. This looks like some packing tape wadded up here. That's why it was wobbling. Part of me wonders if originally this had some rubber feet, at least there and there. And this looks like an air intake, if anything, like air can get sucked in from the bottom. It is plastic, which is curious. Here's our first sign of some damage. These fasteners should just go straight in, but that one is bent quite substantially. So I assume this had a big impact on the front, maybe just during shipping. That might not have been in customs. That's probably why the whole chassis is kind of bent up. My intent with this video is not to try to do any repairs to the board, but at the minimum, I'm going to try to clean up some of this corrosion, using vinegar, since I'm pretty sure the leaking batteries was NiCad, so it's a strong base. So the bottom cover is released. That fastener, the screw, is actually broken. So it didn't bend up the chassis, it just broke the screw and sort of mangled the plastic a little bit. Not the end of the world, since that's just the one that's damaged. This does give us the opportunity to look at the sticker. Model number A6S0300P, assembled in Ireland. And the memory option is an A6SO304. Manufacture date 3258, whatever that means. And we have a serial number A3258146. With the cover removed, we can see we have a sizable speaker, bigger than the ones on the Macintosh. And I can see the final fastener that's holding the side cover on is right there. So maybe I can somehow get a screwdriver through here. Nope. All right, so the fastener is up about there, and I can see there's a hole in the metal chassis, which I can't show on camera. Looks like if you take the monitor out, you could get a screwdriver through that hole, so in this area. So it appears to me the only way to get into that area, is, since it's behind the screen, is to remove the CRT. All right, so let's do that. Let's get the CRT out. Now, of course, this thing hasn't been turned on in who knows how long, probably a decade or decades. So I'm not particularly worried about any kind of charge in the CRT, but don't work on CRTs or take stuff apart that has been powered up anytime recently, because of course a CRT is a big capacitor, it can store a charge, you can get a zap and it can really hurt, and you can drop things and break things. So yeah, be careful. So the bottom two fasteners are out. Now, of course, I can't just take all these out because the CRT will just fall out of this computer. I have to be careful about that. So I'm just gonna loosen those top two. So CRT is kind of loose. And here I just put the Lisa on its backside since there's no more plastic or whatever. And I have this off the edge of my desk, so this side panel's not getting any stress because it is loose right now. I don't want it to be pushed and break the plastic or whatnot. Now I can comfortably take out these fasteners for the CRT without it going anywhere. Okay, so just disconnected the high voltage anode cap on the CRT. And I'm just reaching and getting my hands very dirty, disconnecting the deflection yoke. There are two connectors on the analog board for that. There we go. So that's one of the two connections. And I'm going to reach to the CRT neck and disconnect the neck connector, and slide out the CRT. There it is. That's the Lisa CRT. And take a look down there. Flyback transformers, remote's not on the CRT driver board. And that fastener is down there. Can I get a screwdriver down there? Not that one. I'm really struggling to get that screwdriver in there. There's something I'm missing. I think if I remove the fasteners from this cable bundle, that's the connector down there that obviously goes to the power supply, and looks like the CRT analog board is also through that larger connector. Maybe that'll make some space and I can get this screwdriver down and in there. So this is the connector I'm talking about, and there are some fasteners there that hold it on. So let's see if I can get those off. They're very corroded, so hopefully we don't have any issues with stripping. Oh boy, yeah, those are mega tight. I'm gonna try to use my impact driver. I need to see if I can find the right size bit. It's a smaller Phillips head than the normal screws on here to try to get that off. Otherwise, you could easily just strip those. No, that was a big failure. That did not work at all. I gotta do it by hand. I try to do it by hand here. Oh boy. That is unfortunately stripping. I think the corrosion has just got those fused in there. I think I'm gonna have to drill those out. That screw is so stuck on there. It refuses to turn. There is a screw head on the left side that came out. Oh, both sides came out. Okay, so that cable is free finally. Unfreaking believable. That was ridiculous. That was absolutely ridiculous. Okay, while that helps, I still can't get to the hole without removing the flyback, so I gotta figure out how to get that out next. Okay, there's a fastener there. I think that might be for the flyback, hopefully. No, unfortunately, no. I think that fastener might have been for this thing, because there's a screw there. I don't know, there's lots of screws that kind of go in from every which way on this thing. I think the only way I can possibly get to that is try to use a stubby, but that's not gonna work. Okay, how about this? How about a socket on a ratchet? There's gotta be an easier way than this. There's just gotta be. Actually, you know what? Looking at the plastic panel that's on the bottom, the whole computer's sitting on it, I need to remove that. That's what I gotta take off. So let's use the socket wrench since there's obviously a lot of corrosion there. So there's a couple fasteners in the middle. These two, those two, there. Okay, luckily those screws just seem to go into plastic. That means they haven't fused from the corrosion. Oh, there we go. Oh boy, that's dirty. That's real dirty. Okay, now we can see a lot of the corrosion, and the fastener that's holding this on is right there. Actually, no, I can't get it through that opening. You're supposed to go through the hole that's right there where that flyback is. And looks like the flyback, that's got to be the bottom of it. So there's like a fastener there. I don't know which ones hold the flyback in. It's ridiculous how some of the screws come through that side, others go through this side. The whole thing is just jigsaw puzzle here. Okay, I think the fastener's not very tight, and I can just use this to do it by hand. Oh, there we go. There it is. The last fastener. There's that screw. And now I can free the side panel. Look at that. Nothing's broken, luckily. All right, so we're making good progress. Let's get the analog board off. Okay, so I released the two fasteners on the top of the analog board. I think this just slides out. That's right, it does. 3 screws for the speaker. Wow, there's even corrosion on this analog board. I don't even see how that got to it on the back side here, but unbelievable. Okay, what I'm trying to do is with this connector, there's 2 screws holding it in place. There's one of them. So that one down there where the screwdriver's on, there's a bunch of corrosion on that. So I am concerned. Okay, no, that one. Okay, there, the connector's free. And you see there's a ground loop or goes into there, that screw there. All right, so this other connector, this is the one where everything was corroded. You can see the screws are sort of rusted in there. Those are the ones I had to drill out. Now I really need to take this one out, which the fasteners are on the other side. I guess this is how it should look. There's a screw and a nut that holds those connectors on. Okay, this other one is free. It looks like there's, I guess, a power LED right there. No, that's an interlock switch for the front panel. When the front panel's installed, it pushes there, or closes that connection. So this is the connector that goes down to the flyback, which frees the analog board. Cool. Looks like we have a zip tie there that holds that on. Okay, so the harness is coming out, but some of the wires go down, I think, to the power switch over there, which is right there, along with that keyboard connector. It looks like it's a 1/4-inch audio style jack, or I don't know if it's 2 pins, 3 pins, whatever, for the keyboard. Look at all this that's falling out of the case. All that corrosion, just wonderful. Okay, let's get this nut off this jack. Maybe that'll free up. There's a little PCB back there, it looks like. Again, on the bottom, there's a fastener from this side, then we have ones from the other side. It's just like this hodgepodge. It's absolutely ridiculous. But first, let's try to deal with this flyback. I'm gonna guess these 2 nuts are the fasteners for the flyback. So let's remove those. Yeah, I think that's it because it's kind of moving around now. Just free the high voltage cable, lift out the flyback. There it is, there's the flyback transformer. It's pretty dirty, which means this is pretty high hour, hence the burn-in that we saw all over the CRT. It makes sense. There's a label here. Let's just wipe that off. That's a lot of soot. With the flyback gone, I can get the screwdriver down in there to actually, well, I could have removed that side fastener. So that's the trick. You gotta loosen this cable harness and then get that flyback out of there, and then you can get the screwdriver in there to get this side panel off. Right, so this is the right side of the machine, and I didn't even think about this. I can lift out almost all of these cables. This is that very corroded connector that goes to the motherboard chassis. And boy, there's a lot of green crusty on there. I wonder if the ribbon cable itself is corroded. The fact is, I'm pretty sure all the corrosion has wicked up the ribbon cable itself, because these are the cables that I think went to the floppy drive. Well, one of them did at least. And this one, it's all green and crusty right along the edge where the wire's been cut. So that's the exposed copper. So I wonder if the corrosion has just wicked up the entire cable. Now down here is the little PCB that has the keyboard connector and power switch. Not sure if the camera is going to focus on that, but it's possible to release the ribbon cable. So that frees up this entire potentially corroded harness. Okay, and what's interesting is this cable harness with all the power wires, it didn't even go over there. Well, it didn't go to that little PCB. This connector was over on that side, just sort of tucked down there. This must have been for the hard drive on the Lisa 2/10. There's the entire harness, speaker and all. There's a lot of corrosion on that connector and that connector. So again, I'm worried that the corrosion has made its way and wicked up these cables. So all that's left is the little PCB with the power switch and the keyboard connector. And there are two fasteners, and I got one of them out, the one on the right side. The left side one, it's kind of blocked by the metal structure itself. There it's it, that's the last fastener. Free up the last component, the power switch / keyboard interface module. And this is what I was talking about. That fastener there, as it was mounted, it was half obscured by this metal structure. I couldn't really get the screwdriver onto there. Seems like a bad design. This one here was fine. Notice how it has more clearance, but I don't get what happened here with this one. Well, believe it or not, that's it for all the components inside the case. Everything has been removed from this. There's just sort of plastic clips and stuff that are left, which are fine. Those can just stay in there for the clean I'm going to do to this. Just want to point out all the dust and horribleness that came out of this from all that corrosion. I'm quite sure this machine was smoked around, as in cigarette smoke, because you see all this here? This is a result of cigarette smoke, and I can really smell it on my fingers. So I went and grabbed the top cover, and I have this sitting on top. Now it's fully resting up against the front lip of the metal chassis. And indeed, you can still see that it's still headed towards the right. So there's absolutely a bend in this whole chassis. Now, of course, with all the covers missing, the whole thing is sort of flexible now. And I think what I can do after I've cleaned this thing, because every time I touch it, it just makes everything filthy. Because if I twist the chassis moving the left side closer to the camera, then the top cover starts to align a little bit better. I notice there's a significant bend in this part of the chassis. This is sort of pushed in right about there. So the whole thing's quite tweaked, and that damage we saw on that front plastic where the fastener was snapped out, obviously this thing got dropped probably on one corner and it just bent everything. And I'm pretty surprised that none of the plastics got broken and none of the clips are broken, so that's great, because the metal itself, we should probably be able to loosen all the fasteners. There's a bunch of fasteners to hold the sides on. Once those are all loosened, we can kind of try to shimmy this back into shape or hold it down with some weights and then tighten all the fasteners, and hopefully that should pull it back into shape again. Here's the Lisa card cage motherboard assembly. Things are looking grim. This is the I/O board. Just notice up here in this area, look at all the copper corrosion underneath the solder mask. This little section up at the top, that looks fine. These are the ROMs. But the corrosion is just taking hold in this whole area. Now apparently this IC, this is 9F, U9F. This apparently is a very hard to get, very static sensitive IC. So I'm going to remove this from the board, try to remove it from the board. Of course, there's a ton of corrosion down here. And we will place this into an anti-static bag. It looks like this chip has probably survived. It's definitely got corrosion and green crusties on the pins, but it looks like it's all on the bottom of the pins where it was in the socket. Obviously, it has this fuzz on it, which is probably from the electrolyte or whatever leaked all over the board. But I need to save that chip because I think everything else on this board is pretty much off the shelf and can be replaced relatively easily, except for that part. I'm just getting it with some 99% isopropyl alcohol just to clean off any of that electrolyte that's still on it. All right, so that looks a little bit better. So into some foam. And we'll just keep it in this anti-static bag here for safekeeping. Well, let's take a look at this board again. Look at the corrosion along the bottom edge there. You can just see these components here completely corroded away. Obviously, we have tons of corrosion and rust here. Should be able to replace those without issue. I think that's 25 pin. These look like 25 pin. Now, it's funny, the mouse connector, it looks odd. Is this how it's supposed to look, or was this damaged or something? I mean, normally if a DE9 loses its metal shroud, it's still, well, you can see on the DB25 here how it looks. Doesn't look like that. That's odd. Anyhow, let's try to get these boards out. You can see this thing definitely is bent, the I/O board. It's got these little things here to lift it out, so let's do that. It oddly enough seems to be binding up. Let's try the CPU board. Well, that one comes out without any issue. I mean, it's got some corrosion on the bottom edge there, but it doesn't look like it's made it onto the rest of the board. That's funny. Made in, someone put whiteout or something or paint over that. USA, I guess it said originally. Here's the RAM board. Let's try to get this out. This came out without any issue, except for the corrosion there. Definitely corrosion along the bottom edge, and it's starting to eat away the traces. We'll take a closer look at that in a second. Oh, the back side of the I/O board, horrible, absolutely horrible. Carnage. There we go. I just have to kind of jiggle it, and that is coming out now. Okay, I'm going to remove all the fasteners from this bottom board called the motherboard. Let's get this out. Really need to be organizing these fasteners a little bit better. So these ones are all for the motherboard. This was a little plastic thing on the back. That's the nut for the keyboard cable, CRT, and just all the other random fasteners from the rest of the case. All right, take a look at the carnage on the motherboard. This is bad, really, really bad. I have no idea if these connectors are obtainable, and if they are, like how much do they cost? Clearly, this isn't gonna work. You're not gonna get a working system with this. It looks like MEM1 slot. It's actually cracked, probably from when this machine was dropped. It won't be until I completely clean and wash this before we can even start to see if all these traces are bad or good. But just the fact that you see all this here, it's starting to actually show through the solder resist, bad sign. I'm sure all of those traces are bad. And I mean, it looks like at least one of these slots is good. This one may be savable, but I don't think this one is savable. And I'm sure these types of connectors are completely impossible to get. I think the reason why they use this kind of connector is that the typical boards you stick in, you have to slide them into the chassis. So you have to open these slots first, and that allows you to actually slide the board into the connector and then latch it and clamp it on to the cart. I have all the fasteners off except for that one. And I don't think I'm gonna be able to unscrew that one. This is probably one we're gonna have to break off or drill out. You know, maybe I can clean some of that rust out a little bit. Let's see, that do the trick? Oh, yeah, that did the trick. I was able to actually get that one out. Cool. All right, that is the very last fastener from the motherboard. So this should come out. There it is. The bottom looks actually okay. Really shocked at that. I mean, obviously these edge connectors don't look great, but this side, not so much. So all the green you see is actually the copper corroding. So this is gold-plated copper, something like that. And it's actually the copper underneath the coating that's completely corroding away. So if we clean all that off, we clean off this green, you're gonna have exposed copper. And the problems with that is it just oxidizes again. And it's the coating itself that keeps it from oxidizing. So I don't really know how to prevent that if we try to rejuvenate these by, say, cleaning all this green stuff off. Now, obviously this bottom plate, not a big deal. I can just wire wheel this, spray paint it with some, you know, silver rust kind of coating material, whatever, self-etching primer, and that will be no problem. But this board, on the other hand, I think this might be an actual goner. And here we are at the scene of the crime. Let's remove these horrible things that did this to the board. Yes, let's get these off here. Looks like they're soldered on with 2 tabs there and there. There it is. There's our battery pack. You know, it's funny. It doesn't even look that bad when you look at it here, but just look what this has done to the board. Unbelievable. Now, I happen to have a thing for batteries, old batteries that I'm going to recycle. So that goes in there. This is probably one of the worst and most damaged boards I think I've ever had on the channel. I've seen other people with damaged motherboards from NiCads that have just completely destroyed things, but I just haven't had one myself. Well, correction, I've had batteries, lithium batteries on Macintoshes completely destroy motherboards, but that's different. This is a NiCad battery that did this. And the difference is all the green and crusties and the copper that's eaten away, that's really comes from the NiCad battery. And let's just get a close look at this. Yeah, so this was the socket with the chip I removed, and you can see the socket itself is extremely eaten away. Somehow the chip survived, I think, but yeah, Yeah, this is ugly. This is real ugly. All of this is eaten away. Not sure what this chip is, a TL074. Apple typically labels the chips, so like LS86, LS04. So what's a TL074? Not sure. So we have a normal ROM chip from 1983, 2732, 6504. This is, I'm pretty sure, 6502. Just a limited version, doesn't have as much memory capability because this doesn't have all the address pins. Rockwell 6504, 28 pins, 8K bytes total addressable memory. Moving on, we have a couple 2114 SRAMs. I wonder if that's memory for the 6502, it's possible. We have an MMI PAL, and I wonder if this has been reverse engineered. 1983, 37th week is the date code on this. This is all Jelly Bean logic, a resistor pack, Jelly Bean. That's just normal Jelly Bean logic. Jelly Bean, 8530. It's like a serial, I think this is like a serial controller IC. Keyboard controller 6522, so I think that's pretty much standard stuff, 6522 for both parallel and the keyboard. All Jelly Bean logic, all Jelly Bean logic. Everything's pretty normal stuff here. Not sure what a 26LS30 is, but I think that's pretty much off-the-shelf part. And 26LS32. And on our last row, everything looks pretty standard, easy to get, easy to replace. Here's an on-off switch. Don't know what that does. There's our battery that leaked. Can barely read the markings on the board. Apple Computer looks like. And flipping this board over, we can just get a good view of the horrible carnage that's happened here. We know there's just going to be tons of traces that are just totally eaten away, just gone. This board is gone. A little bodge wire. I didn't mention on the other side there's tons of bodge wires. Up here, starting to look better. I mean, not over here, but in this area. And at the top, seems okay. Apple Computer, 1982. I mean, it's even gotten up to there and just eaten it away. Just bad. Okay, let's check out our memory board. Upper byte, lower byte, so 16-bit system. Everything on here is pretty standard issue. We've got some traces that are definitely eaten away. All these RAM chips are just standard issue. I think we have 512K. If we look at the markings on these ICs, these are 64K by 1 bit. So 64K, 128, total of 256K. And that's replicated on this side. And that tells us this is a 512K memory board. And looks like everything is pretty much Jelly Bean logic. Everything on here, if any of these chips are bad. I wouldn't be surprised if there's some replica board for the Lisa that adds 2 megabytes on a little tiny board like this. On the back side, things are looking pretty good, except for along the bottom edge. That capillary action just started eating this stuff away. But any kind of bad traces here would be pretty easy to fix, I'd say. You know, just little bodge wires, if there's even anything broken at all. Generally, you just have to kind of sand this away, check to make sure the corrosion hasn't eaten things, and then just recoat it. And this board is probably fine. And lastly, we have our CPU board. And this is the one that actually looks the best. Even along the bottom edge, I mean, it's pretty minor corrosion. I don't even see stuff that's like gone up onto the main board. Let's put a little IPA on here, and yeah, look at that. Mostly comes off. It's not like this thing has gotten away completely unscathed. I mean, look at this. See, this is all eaten away. Almost certainly what's happened over here in the corner is just some of the coating has come off, and I think that's probably just some copper that's a little bit oxidized. So I could polish that and then tin that with some solder, and this is probably okay, this board. And on the back side, similar story. It's actually just a little bit better, some green crusty there. Just have to scrape that away. A little bit of the coating's coming off there. See, even wiping this, still some green stuff comes off. So we definitely have cleaning and polishing that would still need to happen on this thing. Yeah, so there's still green stuff coming off on this. Now looking at this board, pretty standard stuff. Got some SRAM up here. Don't know what that's used for. Memory map functionality. Look at that little bodge Apple applied. That's probably slowing down a transition. PAL IC, hopefully that's been reverse engineered. Doesn't look like it's corroded, so it's probably fine. Some more bodges over here. We have an S part, 74S, that's high speed. ALS, pretty high speed as well. Most of the stuff on here is LS logic. A couple ROMs with 1984 date codes. 341.075 and 0176. Anyone know what these ROMs do exactly? There's our Motorola 68000, 8 megahertz part, but I think this thing only has a 5 megahertz clock speed. The only crystal I see on this board is this, 20.375 megahertz. I assume this is divided by 5 to generate the 5.375 whatever megahertz that this thing runs on. So that's the teardown of the Lisa, and things are grim. These two boards, the I/O board and the motherboard, they look bad. These are gonna have to be replaced. Now I happen to know there are replicas for a lot of this stuff, or all of it actually. I think one of the bigger problems is gonna be these slot connectors. If these are replaceable, I mean, at least one of these is good, but the rest of these on this board, not really. And the other issue, of course, as we saw on the I/O board, there's at least one PAL on here. Hopefully this IC has survived, whatever this thing does, the CDP 421. And then the next unfortunate thing about this machine is, besides these two boards being completely decimated, we're missing the power supply. I also don't have a keyboard or a mouse. I don't think either of those are that big of a problem, because I think you can use a regular Macintosh mouse from like the Mac 128. And then I think the keyboard, you can use another keyboard with an adapter, although it won't, of course, look like the Lisa keyboard, but at least you could probably use like a Mac Plus keyboard that has the number pad. I think my next course of action will be to get some plastic trays, and I'm gonna soak these motherboards or these boards in some vinegar just to try to neutralize any of the base that's still on these boards and under the solder mask. Just try to stop the corrosion from happening. Because if you let this go unchecked, especially a lot of these ICs here, it's on the pins, it definitely can damage these ICs. It makes its way through the hermetic seal along the pin and into the body, and then once that's compromised, the IC itself goes bad. And actually we're kind of lucky because the one PAL on the I/O board's up here, and this is the one part of the board where the corrosion hasn't really gotten to it. So if I neutralize all of this by soaking it in some vinegar, for instance, or citric acid or something stronger, for instance, then at least I'll stop the corrosion from happening. And same goes for this motherboard. As for the restoration of this machine, well, it's obviously going to be a huge, huge project, and I have a lot of things on boil right now. I mean, I got to get back to the Plexus B20, right? So once I neutralize the corrosion on, well, the metal chassis and especially on these boards, I'll feel better about letting this machine sit so I can take my time to gather up the parts necessary to try to get this thing up and running potentially. I have to say I'm a little bit out of my depth when it comes to this kind of restoration work. This is not the stuff I normally work on. I like fixing digital electronics, and these are physical problems we're dealing with here. And that's where I'm a little bit out of my depth. So I'm quite sure there's gonna be people watching this video who have a lot more knowledge about fixing these types of physical issues than I do. And I'd love to get your input. Definitely comment down below and let me know the best tactics for trying to recover this stuff. And there's one thing I really have to consider about a machine in this poor condition. I have a very limited amount of time, right? I release videos on a regular cadence. And I kind of imagine that if I were, say, going to really take a deep dive in restoring these boards, like try to get them back to life by removing every component and trying to figure out every bad trace and fixing all those traces, that could make a huge amount of time and really not allow me to make videos on a normal schedule. So I guess that's going to be it for my Lisa triage video. What I'm going to do is I'm going to edit this up, and I think before I do any kind of cleaning or neutralization of any of these boards, I'm probably going to wait for the video to go live. That way people who know more about this have an opportunity to comment, just to give me those tips that I need. This has obviously been this way, corroding for years and years and years, like decades potentially. So I feel that like another few weeks isn't going to really make much of a difference. Even though, like, I have to fight the urge to really just soak this all in vinegar, but I'm not going to do that. I'm just going to wait and see what people think, because I think there's going to be some really good comments that will give me great tips on what I should do next with this machine. So that's going to be it for this video. If you enjoyed it, thumbs up. But if you know you hated me just doing nothing but taking apart a computer, then you know exactly what to do. Huge thanks to my supporters. Their names are on the side of the screen here. They make it possible to do this full time. If you haven't subscribed already, I really appreciate it if you hit that subscribe button, comment down below, you know, all the other YouTube junk. And that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye. And I really got to wash my hands. Ooh.